In this module, we will finish our look at the 4 stages of selecting a motor by looking at the final stage, environment, exactly where the motor will be used. Knowing this will help us select the type of enclosure and cooling method required. We can also make sure that the chosen bearing lubrication provides a long bearing lifetime. Ambient temperature, humidity, and even altitude affect the motor performance, so these need to be determined. When installing a motor over 1,000 meters above sea level, consideration has to be taken to the design, as the thinner air will not only be less effective in transferring the heat from the active parts of the motor, but it will also have decreasing insulation capabilities. Therefore, derating of motor power and upgrading of motor insulation system might be needed. Motors to be used in explosive atmospheres are designed to special requirements and regulations. Equipment is grouped according to the location above or underground and the type of explosive atmosphere it is intended for. Explosive atmospheres are divided into zones according to the risk posed by explosive gas or dust. Equipment protection levels, EPLs, indicate the ignition risk the equipment poses. When selecting a motor for an explosive atmosphere, you also need to consider the required temperature class of the equipment. It depends on the ignition temperature of the flammable gas or dust, as well as their subgroup. If you feel unsure, consult your motor manufacturer, since the consequences of mistakes can be fatal. If the motor is to be used outside, in an area with high dust or is likely to get wet, then the corrosion protection and type of enclosure needs to be considered. All metals corrode with varying intensity under the influence of chemicals and humidity. Selecting the right surface treatment will help lengthen the life of the motor and reduce the need for maintenance. Enclosures offer levels of protection not only against dust and water ingress by IP class, but also reduce the risk of people being harmed by the machine's moving parts. Starting with IP23, which allows for light water spray, rating options for motors go all the way up to IP66, which is both dust-tight and can withstand powerful water jets. Finally, we need to consider the cooling methods. These are defined by the International Cooling or IC codes. The code starts with a cooling medium, which is usually air, but sometimes water or other fluids are used. This is represented by a letter if something other than just air is being used. Then the code has 2 digits to signify the cooling circuit: open machine, enclosed machine, heat exchanger fitted, and the fan type: none, self-driven, or external. The IC411 totally enclosed fan-cooled motor is the predominant standard for industrial applications today. The versatile TEFC is a totally enclosed construction, with cooling air directed over the frame by a shaft-mounted fan. There are other things to consider when you are selecting a motor, such as maintenance and service intervals, and this will be featured in a later module. With this information, you can make the right choices that will ensure a long and productive lifespan for your motor-driven process. In the next module, we will look at installing and commissioning our motor.